Okay, I've got my Tascam 122 Mark II transport out, and I'm going to do a full service on it. There are some SMD capacitors on the motor controller, or not on the controller, but on the motor PCB itself, that have a reputation of leaking and problems. And so they need to be replaced or and upgraded if possible before they do any damage to the PCB. So this deck has been a good deck. I acquired it a while ago, not too long ago actually. It needed a control belt to function, and that's really all it needed. And when I changed the control belt out, which is all I did, to see if it worked okay, and it did. And so I put it aside and knew that I would get back to it here and do the capacitors. So comes apart very easily. It comes out of the case very easily. There's a lot of wires to do some management with. This 122 Mark II is a very desirable deck because it was built very heavy duty, used in radio stations, production type work, and Tascam did a really beautiful job maintaining this, maintaining the mechanical integrity of the deck, not using a lot of plastic, using a lot of metal parts. You can see that it's mostly metal, very few plastic parts, and the plastic parts that are there could be remachined in metal to keep the deck going. Taking off this joint PCB, I think they call it. So there's the motor PCB on the back there, and I'm taking it off. There's 3 screws. Those screws have lock washers on them right there. And I'm taking a look at it while I'm kind of doing this, and I'm seeing that the 2 bipolar capacitors have not been done, but it's looking like the others have been done. You can't really see it in the reflection here, but those other look like they've actually been done before. I'm just desoldering it from, there's 2 solder joints on the side there that need to be removed so that I can take the board completely off. Let's get it focused there. So those are off, and a little bit more wire management. It's starting to look like somebody's been in this before. I've been into a couple of these, and I think Tascam did a little bit better job. All right, so let's look at the windings here. The windings look good. There's no discoloration. It's fairly clean in here. A little bit more wire management. There it is. A little bit more wire management. That gray wire there, I'm looking at it and it's winking at me. You can't see it in the video, but what I see later is it's only being held on by a couple of strands. And I should have just pulled it, but in the end, I resoldered it, cut it back and resoldered it. It was it was not a good not a good job on there. Okay, so now you can see the SMDs, those, 1, 2, 3, 4, 5, 6, 7 SMD capacitors that are troublesome. The two I'm working on mostly there are the ones that don't have the polarity markings on them on the top. They're bipolars C12 and C14. I can see that those haven't been done, and I'm kind of looking at the others, and I'm seeing that they have been done. And they look to me like they are actually fairly recent and high quality Panasonic. Yet it definitely looks like those have been done before. So let's do the C12 and C14, and we'll also do that C2, which is kind of an enhancement to stabilize the speed. So the way I do this is I clip these off because I don't have the proper soldering iron. I'm pushing down on this and doing it parallel to the leads, so there's no chance they're going to lift the pads. The key is pushing down to make absolutely sure that there's no chance that the pads will lift, and it's usually not quite this difficult, but I'm working around a camera for the first time, so it's more difficult than it normally should be. Got off there. So now just a little touch of the soldering iron will pull the rest of that lead right off of there. I'm doing everything I can to stay off of those pads as much as possible. These are delicate and old, and so I want to do everything I can do to stay off of them. One of the ways that's possible is by thoroughly cleaning them, getting all the old solder off. That solder oxidizes. It has all kinds of problems when you're trying to resolder to the board, and it's very important to try and stay as clean as possible. I'm going to give them a little cleaning here with some alcohol, and when I say alcohol, it's IPA, 99.7% or something, and these are electronic swabs. They are not Q-tips. I never use Q-tips on this sort of thing because the fibers break off and they contaminate the solder joint, and I never want to do that. So I'll clean them with these electronic swabs, and then I'll go back with one of these foam pads and make sure that there's nothing on there to get in that joint and contaminate it. I'm going to work on this C2 pad, or this C2 capacitor now. I just want to get it off there. I'm going to replace it. Kind of a recent upgrade that and the solder's old, and so I'm going to add a little bit of new solder to it and just get that boop, just get it off there. Now clean that pad. There's that little guy right there, the little tiny thing, and he's out of there. I need to get these pads cleaned up also equally. And scrub them down there as best I can. I've already got flux on there. Having a little bit of problem on that left pad. It doesn't want to come clean. It's oxidized, and I work on it. I think I got it there. It doesn't look so good, but when I go to clean it, you see that it cleans up pretty nicely. I'm going to add just a little bit of fresh solder to it, work it in there, and you can see that is just not really wanting to clean up. It's adhering to part of it, but not all of it. But once I get this on there and scrub it a little bit more, now it's nice and bright and shiny. And when I take the alcohol and the swab to it, it cleans right up. So now I'm going to tin them. I'm using some of my favorite paste flux. And this is what it is here. Kind of hard to get in the photo. PF400 works really well. So there you can see I'm just on and off that pad very quickly. I'm not taking any time at all to give it any sort of problem of lifting or overheating. Now let's clean it up one more time here. This flux does not actually require cleaning off the board, but I do it anyway. I want things to be tidy on here. Give it a little wipe with a foam pad, clean one. I go through a lot of electronics wipes. Okay, so I'm replacing this with conventional electrolytic capacitors. Just bending them up to fit, doing what I can to make everything nice and clean and tidy. I do use wire benders. I'm trying to keep from not doing a 90-degree bend. I want to have a little radius in there. All right, I like the way that looks. Let's clip them off to the right length. Yeah, that looks good. And clean them leads up. A little bit of IPA again. Foam brush, foam pad, foam wipe. Okay, I've cleaned my tip. I'm just going to tin just a little bit on there. I'm not even worried so much about tinning these. I just want to have a little bit of solder on them so that I can set them in place quickly, and then I'll worry about getting them seated correctly. These are small for my fat fingers, so I'll use a little pair of needle nose here. And all I want to do is just get it seated. Just pop it on there, put it in place. Cleaning my tip between every 1 or 2 joints. I never let it go past 2. I always want to have a clean soldering iron there. This one's giving me a little bit of problem because I'm trying to work around a camera and it's very difficult. I haven't done this before, and I'm learning to respect the people that do it all the time for YouTube and other videos. Ordinarily, I would position this thing where it's easy to see, but I can't do it here with the camera. So, all right, so all I'm trying to do there, and you see I'm getting in and out of that joint on and off as fast as I can, just to position it. And then I'll go back and I'll get it soldered after everything's cool again. Here's my little film capacitor, my little C2. It's 1,000 picofarad or picofarad, however you want to say it. What I'll do here is, I'm just repositioning my leads a little bit. What I'll do is I'll come back and press down on the component while I'm soldering it on the board. I want it to be firmly seated on the pad, not just floating in a blob of solder. Now reheating it, I'm getting the amount of solder I need on there. And then I'm reheating it while I'm pushing down on the component to seat it onto the pad. And because everything's so clean, it only takes just a very tiny amount to do that. And I'm not overheating either the component or the pad. It can be problematic. Sometimes it's hard to do, especially when you can't see what you're doing the way you want to. But there you go. I heat it up, push down on it, and seat it right on the pad. And that one I just pushed a little bit too hard and I bent it down there. I'm not editing any of this out because this is the reality of working on these small components like this. It can be difficult. Okay, I got it back where I want it here. I clean my soldering iron again, and I'm just touching it and pushing it down on there, and that's it. It only takes that tiny bit to get it on there properly. Now this one, I didn't have very much solder on it. I forgot to build it up, and so I touched it again. And there we go. Now I'm pushing down on it, just touching it, and you could almost even see it move down onto that pad and settle the way it should. Looks like I need to do it one more time. It's really not this difficult when you're not filming it. All right. This one's visible, so it's much easier to see. I'm just building up my puddle there a little bit, particularly on that one that gave me so much trouble. I just want to make sure it's really seated down there. So there, I just touch it, push it down, and I'm off of it. If your tip's dirty, if you have contamination in the joint, if the solder's dirty, of course I even clean the solder, that won't happen. So I just clamp these boards in a little clumsy clamp, a woodworking clamp. They work really well. I just want to clean up the two pads where the wires come through right there. I'm going to add a little bit of that flux. Now you're seeing a little bit of movement on one of those capacitors there. I didn't see that while I was working on it. I saw it after the fact, and I'll talk about that later. I actually go back and replace all those capacitors because I saw that while I was editing the video. So that was a really good thing to edit the video, to make a video of this, because this deck was functioning fine. But that was like a little loose tooth there that I went back and replaced all these others later, but I didn't see it until I was working on the video. Okay, so let's just quickly tin those two corresponding wires. This old solder, or solder for our northern friends, this oxidizes, and sometimes it gets really hard to tin it or to remelt it. And I don't want to dwell on these joints, and I don't want to dwell on this wire, and I don't want to get soldered down underneath the insulation or even a flux down there. So I'm cleaning them, and it's not taking. I just cleaned it. It's not taking the solder, and so I'm adding a little bit of flux to it here, and a very tiny amount. It doesn't take very much, but I'm trying to avoid getting any of the flux or any solder underneath the insulation. So there, that's all it takes, just a little tiny bit to get it back where it needs to be and be able to wet out the joints quickly and not dwell on these things. So I'm just going to clean it off again. Try to keep any of the flux from wicking its way down into the underneath the insulation, into the wire, into the cable. And so I'm good. I'm happy with that. So let's now service the capstan and the capstan bearings. I'm using a little bit of synthetic oil specifically for capstan shaft bearings, sintered bronze bearings from a company called Nagravox. And that's the right amount to use there. It doesn't require any more than that. That's the back side. I want to do the front side also. So this is the front side of the bearing. Wipe that in there, and that will be good for another generation or two. It just doesn't need very much. Everything's clean. Too much. I have the capstan flywheel and shaft assembly. Giving it another look, blowing any dust or anything else off of it. Popping it back in there. I just want to feel if there's anything there I need to be aware of, but I kind of already know there isn't because I've run this and I know that it operates correctly. All right, let's take a look at the windings and clean off the grease. That's on the motor side. A little tiny bit of graying there, but the grease is still there. I'm going to run my little probe in here just to see that it's still supple and that the grease is still good, and it hasn't dried up. So this has been maintained, or at least taken care of. This is what I use, this Krytox synthetic lubricant. It doesn't take very much. We're talking that's sufficient for another lifetime on that little bearing. And then just another drop on there. And that's it. Anything more than that is problematic. All right, so I'm happy with everything I see so far. That gray wire there is still winking at me. It's bothering me, but I haven't dealt with it yet. I will here in a minute. Just position that back in place. This PCB kind of locks in place. All right, let's just put that back together quickly. I put 3 screws in loosely and then tighten them up or torque them at the end. I'm trying to get those wires back into that PCB, but it's very difficult in the position I'm in, so I give up and turn the video off. Now that I have them back in place, and I have everything tinned, the pads and the wires, nothing will be overheated. Everything will be fully shiny and wetted out quickly. Done. I don't have to hold on it. I don't have to dwell on it. I'm in and out. I didn't get quite enough on it there. There we go. That's it. That's all you need. So you can see this gray wire's off now. It finally got to me. And the reason why it was so bad is because it was only hanging on by a couple of threads. Now I've cut this off and you can see it's just not taking any solder. So this is an oxidized cable. I'll put a little bit more flux on it and give it one more try. Clean the tip, get to it as fast as I can, and there finally I got it wetted out. That piece of wire was cut and stripped and cleaned, and I was still having trouble getting it to wet out. But I finally got it, and now I'm happy with it. Clean it again. I'm trying to keep the flux from wicking underneath the insulation. I'm going to put just a little bend on it here, and again it's going to be a wire bender, not just a solid 90 degree, a sharp 90 degree bend. It's going to have a radius in it. And that will be there for a long time. All right, I'm happy with all that. So I like all that. Let's give this thing a little cleanup. I'm just going to use the brush off a can of Flux Off. It's an ESD brush and some isopropyl. And even here, I still missed that loose tooth capacitor. So it just goes to show that making videos is harder than normal, because I think I probably would have seen it if I wasn't trying to be quick and not extended on the video and so forth. But so I'm cleaning all that off and getting ready for part 2, and I hope you'll join me for that one.